Hey everyone, welcome back to our Python programming series. Today we are diving into Python typecasting, the process of converting one data type to another. Typecasting is like giving your data a new form so it fits your program's needs, in turning a user's text input into a number for calculations. Whether you are building a shopping app, processing survey data, or creating a game, typecasting is a must-know skill. In this video, we will explore Python's typecasting functions, walk through real-world examples, and share tips to avoid errors. Let's start with the basics. What's typecasting? In Python, it's about changing a value's data type like converting to a string to an integer. Let's say to an integer from a string as a comment. So, a float to a string maybe a float to a string if needed, and maybe a list to a set, a list to a set. So you might need unique values, so you convert lists to sets like this. Each data type in Python, like integers or strings, has specific rules for how it's stored and used. The casting lets you transform data to match those rules. For example, imagine you are building a quiz app where users enter their score as text, like 95. To rank them on a leaderboard, you need that as a number. Python's built-in functions such as integers, such as floats, sorry, floats, str, and list, tuple, set provides functionalities like this. So you can convert one data type to another using these functions. But you have to be careful. Invalid conversions can crash your code. We will code through practical scenarios. Alright, let's simulate a user entering the number of apples. I'm typing bottle underscore input equals 5. But I will write in quotes. So it's a string now. To use this in math, we need an integer. So I'm writing bottle bottle int equal to integer bottle input. Now, if I run it directly, you can see two different variables. One is string, as can be seen in here, and one of them is integer. So our type conversion is successfully completed. We can say, great, we converted the string 5 to an integer, and the type is class int. Now we can use bottle underscore int for calculations, like multiplying by price. So let's try it. Let's write print bottle. On first try on the string 1. As you remember from the previous videos, it repeats the string because you use multiplying operator on a string, so it will just repeat, it won't multiply. Now let's write bottle int multiplied by 10, or we can write 2. Now let's run it. As you can see, it says 55, but this 55 is not true. It just repeats the string 5 two times. So it outputs as 55. But if you take a look at this statement, for this statement, it outputs 10. So this one is true and we can perform the operation. Now let's handle a weight input like 2.5 kilograms. I am typing weight underscore input equal to 2.5. Now I will write weight underscore float is equal to float weight input. Now let's print type of. As you can see, we can get the type using this function weight float, and just print weight float. Okay, so here we go. The class is float. Okay, the type conversion is successful and the value is 2.5. We successfully turned 2.5 string 2.5 into a float confirmed by class float. Trying to convert 2.5 directly to an integer fails because integer function can't handle decimals. The integer function can't handle decimals. To fix this, you will use int in parentheses, float in quotes, parentheses again and quotes, 2.5, like this. Let's try it. Print int float 2.5 and see the result. Okay, it outputs 2 because you convert it to integer. This part goes. The decimal part is removed. So if the decimal part is removed, you can think it as an integer now. This is critical in apps where you need clean numeric data. Next, let's convert values to strings, which is key for displaying data or building messages. Strings are Python's text type, and you will often need to turn numbers into strings for user interfaces, logs, or reports. Imagine you are coding a restaurant app that calculates a bill total like 45.99 and you need to show it in a receipt like total colons like this. Let's write. You want to show it like total $45.99. You want to show like this. That number needs to become text. Let's code this with, let's say, let's set up a bill total. I'm typing bill total equals 45.99. So it's $45.99. So it's a, let's write float. And total str, the string version, is equal to, remember what we can use here, str function. So inside the str function, inside parentheses, we'll write bill total. Okay, and our message is, let's write string. Our message is total dollar symbol and total str and print message. So as you can see in the output, the price showed up and you can see it clearly. There we go. We converted 45.99 to a string and class str confirms it. Yeah, as you can see here, it's also can be seen here. So its class is str. The message looks perfect for a receipt. The f string is a clear way since it handles conversions automatically. In a restaurant app, this is how you will display totals to users or print receipts. You can also use f-strings here. Now let's explore typecasting with collections, lists, tuples, and sets. These store multiple elements, and converting between them is useful for different tasks. For example, in a to-do list app, you might use a list for editable tasks, convert it to a tuple for a fixed plan, or use a set to remove duplicate entries. Let's code a task management scenario with pronunciations. Let's code a task management scenario. Let's create a list of tasks first. So let's create a list of tasks. I'm writing, let's type tasks equals write code, write code, test, deploy. To make it a fixed tuple, I'm writing task tuple equals tuple tasks. And let's print them both. Print tasks, comma, tasks tuple. You print it out, you can see one of them is list, the first one tasks, and task tuple is tuple, as you can see from the parentheses. You can observe it by that. And okay, now for unique tasks, let's try another thing. Let's write deploy, deploy, and run it. So as you can see, there are duplicates both for list and tuple. How we can fix that? As you remember, sets do not accept duplicate elements, so we can convert our list into a set. How we can perform that? I can write tasks, tasks, no dup. So no duplicates. And or simply we can also call unique tasks. This is better. So let's say tasks, okay, and print unique tasks. So if I run it, as you can see, write code, deploy, and test. And these are unique tasks that exist. We turned a list into a tuple confirmed by class tuple, as you can see from here. Tuple 4 elements it says. And we turned it into a set afterwards to show up just unique tasks. You can reverse it with lists if you don't want that. So let's say old list is equal to list unique tasks. So print old list, but it will remove the duplicates. So your list will come up with 3 elements only because it removed the duplicate one. So as you can see, it's again list, but it's useful if you want to remove duplicates from a list and convert it to list back. Typecasting can trip you up if the data isn't right, like converting a word to a number. In real apps, you need to handle errors to avoid crashes. Let's code a safe input scenario. Imagine a user enters their age but types a word. I'm typing user input. User input. User input is 20. Okay, so if I try int user input, int user input, let's say int input is equal to user input, and let's try to print it int input and run it. Invalid literal for integer with base 10, 20. So it says it's not appropriate. It failed. So I have to use a try except to prevent crashing. Otherwise, your application would raise an error and crash, so user will get frustrated. So you don't want that. You need to use try and except. So what are try and except? We will cover in detail in the next videos, but it helps you to prevent any error and control your program safely. So let's write try. After this block, we will use indentations. You'll also see it later. And let's write except typecasting is failed. Let's say uh, not that. Okay, it's not found. And int input, let's say. Let's assign a default value if it does not perform successfully. Okay, if if the typecasting fails, we will assign 0 to our variable. So and print out typecasting is failed. So let's try it again. Okay, it says typecasting is failed and the output is 0. So we have safely managed the type conversion. And that's our deep dive into Python typecasting, from converting user inputs for a grocery app to building receipts for a restaurant. Typecasting is a core skill. Try these examples in your projects and let us know in the comments how you are using typecasting. If this helped, hit that like button, subscribe, and ring the bell for more Python tutorials. Thanks for watching and happy coding!